Hi, I'm Kashyap from Young Ones. In this video, we will talk about Morse code. We will discuss why Morse code was invented and how to read it. We will also look at its applications. Morse code is a method of transmitting textual information in form of a series of on and off tones, lights, or clicks that a trained listener or observer can easily understand without the use of special equipment. It was invented in the 1830s and 1840s by Samuel Morse and Alfred Vail for the use with telegraph, an early form of electronic communication system. Americans initially used Morse code primarily in the context of telegraphy. Morse code employs a unique set of signals such as dots and dashes rather than letters of alphabet to represent the phonetic elements of a language, showcasing a distinctive encoding system for communication. The invention and widespread adoption of the telegraph system in the 19th century revolutionized long distance electronic communications. It is still used in amateur radio operators and some emergency services today. It is also used to teach telegraphy and can be a useful alternative to written or spoken languages for people with certain disabilities. In the complex landscape of communication, Morse code, often described as God's gift to connectivity, tells a story of simplicity and universality, where the divine precision of dots and dashes surpasses language barriers. American Morse code became instrumental for the first time during World War II as a means of communication of text messages, particularly in distress situations, sending distress signals. Employed extensively by the US Navy and Coast Guard, Morse code played a pivotal role in relaying crucial information via telegraph lines and radio waves. Its simplicity and efficiency made it an indispensable code system for encoding and decoding messages. Learning Morse code became a vital role, especially for telegraph operators who used a Morse code key to send electrical pulses that translated into dots and dashes representing English language, numerals, and even Latin characters. This code system, originally designed for electric telegraph, found application in various forms of telecommunication system, extending from early use of telegraph lines between Washington DC and Baltimore to the playback of Morse code messages over radio. In the early days of telecommunication, operators mastered the art of Morse code by engaging in rigorous practice sessions, perfecting their skills through playback of recorded signals over telegraph lines. Even today, Morse code retains significance, particularly in emergency situations and among hobbyists, showcasing its enduring legacy in the evolution of telecommunication systems. The widespread adoption of Morse code in the 19th century connected communication network not only across America but also bridged the Atlantic, enabling swift transmission of messages between North America and Europe via telegraph lines. During World War II, British operators extensively used Morse code for covert communication, sending encrypted Morse code messages to coordinate strategic operations. The effectiveness of the British reliance on Morse code played a crucial role in maintaining secure lines of communication, allowing for discreet exchanges of information in the midst of wartime challenges. Use of Morse code by British intelligence became an integral part of their efforts, demonstrating the code's enduring significance in military communication strategies. Morse code has several applications. It is used in telecommunication, especially in situations where voice communication is not possible or practical. It is used in aviation and nautical industries for sending distress signals, traditionally known as SOS signal. Amateur radio enthusiasts and ham radio operators often use Morse code as a form of basic communication. Morse code has been used in assistive technology to provide communication capabilities to people with disabilities using a series of dots and dashes to represent letters and numbers. It has also been used in military operations for secure and discrete communication. Morse code is made of two basic elements, a period and a hyphen, representing dots and dashes. In Morse code, dots are short bursts of sound or light, while dashes are long bursts. Such signals were used for long distance communications. Letters of the alphabet are represented by distinct patterns of dots and dashes. In English, the letter A, for example, is represented by a single dot followed by a dash, whereas letter B is represented by a dash followed by three dots. To read Morse code, you need to familiarize yourself with these combinations. You then interpret the series of dots, dashes, and spaces you receive into the corresponding characters they represent. So after we have seen how each letter can be represented into their Morse code, we will try to write a Python program that will convert a given string into a Morse code. So let's get started. We already have a dictionary created with each letter from A to Z and the numbers from 0 to 9 representing the key inside the dictionary and their Morse code representing their values respectively. So here is the dictionary. So let's have Morse code dictionary. And here it is. We can refer to this dictionary and you can also write it down in your program. So after we have created the dictionary for each letter and number and their particular Morse code, the next step is to take the input of the string. So take string input. For this we will make use of a print function where it will ask you to enter a string. Then we'll have a string is equal to input. So after we have taken the input, then we are going to call Morse code converter function. Let's name the function string to Morse and provide string as the argument in this function. Next, we will define the function, and the function will have the main part of the converter, which will take each letter of the string one by one and convert it into its respective Morse code. So let's go ahead and define the function. So let's define string to Morse code function with string as argument. Inside we will have Morse code as an empty string first because we are going to make a string of Morse code. So first let's have an empty string. We will keep on adding one Morse code at a time with respect to the letter that we come across. We will apply a for loop on the given string. So let's say for S in string, this means for each letter in the given string, we will first check for empty space. Because we do not have Morse code for empty space is just a simple blank. So for that we will say that if S not equal to an empty space. That means if the letter is not a space, if it's a letter or a number. In that case, we will say Morse code string is equal to Morse code string plus Morse code dictionary. We will go to the dictionary, we will refer to the particular letter. So the letter that we have is S dot upper, because all the letters inside the dictionary are uppercase. So we will convert the given letter into an uppercase, and that's going to return us the Morse code of that particular letter. And then we will add one space after each letter. Because in Morse code, after every letter, there is one single space. So we don't want to mix up all the Morse code together and it becomes confusing. So we want one space between each Morse code, or you can say that between each letter. Then we will have an else condition where we will say that if there is a space, then we will add a space to the Morse code. So for example, if there are two words in the string and there's going to be one single space between the two words. But when we are going to convert that into a Morse code, then each letter will have one space between them, and there will be two spaces between two different words. So no space will be converted into a single space, and one space in string will be converted into two spaces in Morse code. And finally, we are going to print the Morse code. So let's go ahead and run the program and understand how we are able to convert the string into that particular Morse code. So let me run the code. Let's say first we are going to enter one single word. So I have Morse as the string, and let's see the output. So here we can get the conversion of the string into the Morse code. Now let's try to verify the output. If we go to letter M, we have got two dashes. So yes, we have got two dashes over here. After that letter M, we have got one space. Then letter O. In the dictionary, letter O is three dashes, so we have got three dashes over here, so that's good. And then again we have a single space. R is represented with a dot, dash, and a dot. So yes, it is the same way. That's good. Letter S is three dots, and letter E is one dot. So we have got all the letters converted into the Morse code. And now we can also see that there's one single space between each letter. So basically it does not create any confusion between the letters. Let's run the program once again, and this time we will try to enter a sentence. So let's say this is Morse code. So let's understand this conversion. So the first letter here in this word is T. If we go to the dictionary, we find out that T is represented by one dash. So yes, we have got one dash and a space after that. H is represented by four dashes, so we have got four dash. Then I is represented by two dots, we have got two dots, and finally we have S. So S is represented by three dots, we have got three dots. Now there's a change of word. If you look at here, we have got two spaces between these words. So two spaces means there's a change of word. One space means there's a change of letter in the same word. So this is how we can make sure that the words are changing. So one single space means there's a change of letter. Two spaces means there's a change of word. And this is how we have got the Morse code of a given string. So in the previous clip, we have seen how to take a string and convert that into a Morse code. You can write the program on your own and try to convert strings like SOS, help, and many other strings and convert them into a Morse code and see how they turn out. You can also take the project further by using a camera to read the Morse code signal from blinking LED and decode them into text. This requires a little knowledge of image processing and computer vision techniques, as well as programming skills in Python and OpenCV. While challenging, this project can be a great way to explore the intersection of hardware and software and to gain hands-on experience with computer vision and signal processing. With a little bit of creativity and tinkering, the possibilities for using a Raspberry Pi and other devices to decode and transmit signals are endless. So thank you so much for watching this video. We'll see you in the next one.